Kuzampola. Welcome to Bhutan e-learning program. My name is Mohan Chetri. Today I'll be taking you through chemistry relation for Key Stage 5, and the topic that we are going to learn today is amines. When you say amines, today we are going to study about the definition of amines. We are going to look at how to write the IPC name of amines. We will also compare different types of amines. We'll compare the basicity of different types of amines, and finally we'll also look at the general method of preparation of amines. Now, by the end of this lesson, we will be able to first define amines, second compare different types of amines, third write IUPAC name of amines, fourth compare the basicity of different amines, and last explain the general method of preparation of amines. So by the end of this lesson, we should be able to cover these areas. Now, first, what is amine? Now let's look at amines. Amines, as you can see here, it's a derivative of ammonia, which is obtained by replacing one or more hydrogen atoms of ammonia by alkyl or aryl groups. So it's a derivative of ammonia in which one or more hydrogen atoms of ammonia is being replaced by either alkyl group or aryl group. Now, before we go inside, I just want to talk a little bit about the structure of ammonia here. Let's look at the structure of ammonia. Ammonia, nitrogen, atomic number of nitrogen 7. So in ammonia, even though there are 5 electrons in its valence shell, 2 and 5, 3 are used for bond formation with hydrogen atom, and 1 lone pair of electron is left on top of it. So we need to keep this one in mind when we study about amines, because this will be the main area that we will be focusing today. So when these hydrogen atoms are replaced by alkyl groups or aryl groups, then that becomes amines. So let's look at this one here. So this is ammonia, and you can see 2 lone pair of electrons which is there on nitrogen atom. Now we are adding alkyl groups here. So as we add this alkyl group, we will be replacing this hydrogen, and then we'll get amine. This is primary amine. So you can see we are replacing. So it's a derivative of ammonia. It's a derivative of ammonia in which is obtained by replacing one or more hydrogen atom by alkyl group here, and then we look at by aryl group. We'll get another compound like aniline. So these are amines, and amines are derivative of ammonia, which is obtained again by replacing one or more hydrogen atoms from ammonia, either by alkyl groups or by aryl groups. Now let's look at classification of amines. Broadly, amines are divided in 3 types: primary amines, secondary amines, and tertiary amines. It is based on the number of hydrogen atom that is replaced from ammonia. Now let's look at primary amines. So we have ammonia and 1 alkyl halide here. So what's happening? Now alkyl group is coming inside and then forming a bond with nitrogen atom, and the hydrogen atom is replaced by this alkyl group. Hence we get this primary amine. This is the general structure of primary amine. R can be anything. It can be methyl, it can be ethyl, it can be propyl, butyl, any alkyl group. So therefore this is a general method of preparation of amines, primary amines. Now let's look at a specific method. So here we are taking bromomethane as our alkyl halide. So when you take this alcoholic solution of ammonia with bromomethane, then we get this product called methane amine. Now you can see here this hydrogen atom which is present in ammonia is replaced by this methyl group there, and this goes out with bromine as hydrogen bromide. The general formula of amines are RNH2, because from out of 3 hydrogen atom which is present in ammonia, 1 is being replaced by alkyl group. So therefore it is a primary amine. Now let's look at secondary amine. Now secondary amine, where 2 hydrogen atoms of ammonia is replaced by alkyl group. 2 hydrogen atoms are replaced by alkyl group. Now as you can see here, we are taking 2 molecules of alkyl halide here, And then what we get, now this hydrogen is replaced by one alkyl group, and this hydrogen is replaced by another alkyl group, leading to the formation of secondary amine. Now, I want to emphasize here that this alkyl group can be of same type or maybe of different type. Maybe this can be methyl and this can be ethyl, or maybe both can be methyl or both can be ethyl. Now, this is general method of preparation of secondary amines, and this is a specific method. So you can see here we are taking 2 molecules of methyl bromide here, and then we are taking ammonia. So when they react, 2 hydrogen atoms of ammonias are replaced by 2 methyl group, giving us dimethylamine. So this is a secondary amine because 2 hydrogens are replaced. So in case of secondary amines, now out of 3, 2 hydrogens are replaced. So here we have alkyl group, here also we have alkyl group. So now we are left with only 1 hydrogen. So the general formula will be R2H, R1, R2H. Now these are amines in which 2 hydrogen atoms of ammonia are replaced by 2 alkyl groups. Now these alkyl groups can be of same type or maybe of different type. Organic compounds which contains only NH as the main functional group are known as secondary amines. Now let's go to tertiary amines. Now this is tertiary amine. Let's look at this one. In tertiary amine, all the 3 hydrogen atoms which are present in ammonia are replaced by alkyl group. Maybe same type of alkyl group, methyl, 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 or maybe different types of alkyl group. So here, let's look at this one. We have 3 hydrogen atom which is present on attached to nitrogen atom, and now we are taking 3 molecules of alkyl halide. So all these 3 hydrogens will be replaced by 3 alkyl group here, and it results in the formation of tertiary amine. It results in the formation of tertiary amine, and in the meantime, you will get 3 molecules of hydrogen halide, and it can be anything, halide, so we are taking X. So this is general method of preparation. Now when you look at a specific method of preparation, we are taking 3 molecules of bromomethane, and then we are reacting with ammonia. Now we can say all the 3 hydrogen atoms are now replaced by alkyl group. Now this is tertiary amine. So now there is no hydrogen left on nitrogen atom because all the 3 hydrogen atoms which are present there are being replaced by alkyl group. Hence, it becomes tertiary amine. So general formula of tertiary amine, R3, R1, R2, R3, N. So those amines in which all 3 hydrogen atoms of ammonia are replaced by 3 alkyl groups are known as tertiary amines. An organic compound where the functional group is all 3 are attached. So it is nitrogen atom does not have any hydrogen with it now because all the 3 hydrogen atoms are replaced by alkyl group. Now nomenclature, as we know that whenever we name any organic compound, there are 2 systems of naming them. One is common name and another one is IUPAC name. So first let's look at common name of amines. Now look at this. When you write the common name of amines, we write the name of alkyl group first and followed by amine. So as you can see here, the alkyl group that we have here is ethylamine. So that's why ethylamine. If you have alkyl group as methyl, so methylamine. If you have propyl, propylamine. So it's very easy to write the common name of any amines because we just have to write the name of alkyl group followed by amine. Now, this is for primary amine, but what if it is secondary amine? What if it is tertiary amine? So let's look at this. Second, let's look at this one. So if you look at this one, we have 3 alkyl groups attached to nitrogen atom. We have methyl group here, we have ethyl group here, we have propyl group here. Now how should we name them? So if you have 2 or more alkyl groups attached to nitrogen atom, then the name of these alkyl groups are arranged according to their size. So if you look at this one, first the smallest one is methyl, so that should come first. Then ethyl, then propyl. So methyl, ethyl, propyl, amine. So when you have two or more alkyl group attached to nitrogen atom, then we have to name this alkyl group according to their size, followed by amine. Maybe let's take one more example here. Let's assume this is secondary amine. So I'm drawing a structure here, nitrogen. So we have methyl group, we have C2H5 ethyl group, and then we have hydrogen. So this is secondary amine. Now what will be the common name of this compound? Then, as we said, it has to be number 1, methyl, number 2, ethyl amine. So the name of this compound will be methyl ethyl amine. Why methyl ethyl? Why not ethyl methyl? Because the name of alkyl group is written in such a way that it is based on the size of alkyl group. So since methyl is smaller in size compared to ethyl, methyl should come first. So similarly, as we have discussed earlier, here in this case, this is tertiary amine where all 3 alkyl groups are there. So therefore, when we name them, so first methyl, ethyl, then propyl. So methyl, ethyl, propyl, amine. So this is a way of writing common names of amines. Now let's look at if the same alkyl group occurs twice or thrice on the same nitrogen atom, then prefix such as di, tri are used. For example, let's look at this one. Nitrogen atom, one methyl, and hydrogen. So dimethylamine. Dimethylamine. If you have another methyl group here, then we'll write trimethylamine. So if similar type of alkyl groups are attached to nitrogen atom, then we'll use the term di for 2, we'll use the term tri for 3. So dimethyl, diethyl, like the way it is named here, methyl, 1, 2, 2 methyl. So instead of writing 2 methyl, so we write dimethylamine. For example, let's take this one. So again, let's take this one, CH3, CH3, CH3. So we have 3 methyl group. So then we write tri. So the name of this compound will be trimethylamine. But what if it is ethyl, C2H5? And what if it is butyl, C4H9? Then, as we have already discussed before, it has to be according to the size. Methyl, ethyl, butyl, amine. So now let's look at IUPAC name. IUPAC name. Writing IUPAC name of amine is very, very easy because you just have to write the name of alkane. From there, remove E and add amine. Then it becomes IUPAC name of amines. Now if you look at this one, first compound, CH3, CH2, NS2. So what's the alkane? How many carbons are there? 2. So it should be ethane. Ethane minus E plus amine becomes ethane amine. Ethane. So let me explain that one here again. So if you look at this one, how many carbons are there? There are 2. So I'll draw that structure here also. CH3, CH2, and H2. Now, how many carbon? 2. So accordingly, alkane name will be ethane, E-T-H-A-N-E, plus amine. And the rule says that E has to be removed because 2 vowels cannot go together. Therefore, ethane, A-M-I-N-E. This E is removed. So alkane minus E plus amine. Similarly, if you look at second example here, how many carbons we have? 1, 2, 3. Propane, right? Propane minus E plus amine. And here we are giving the position because amine is present on first carbon. So 1, 2, 3. So 1 propane in or propane 1 amine. Okay. Again, I'll write that one here. 1 CH3, CH2, CH2, and H2. Carbon number 1, because functional group is attached here. Carbon number 2, carbon number 3. So now 1 propane, P-R-O-P-A-N-E, propane. Now what the rule says, remove E and add amine. Please remember, there should not be any space between this. There should not be space between propane and amine. It should be a single letter word. So this is the second example. Now, what if you have two different alkyl groups? Then how are you going to write the name of IUPAC name of such compounds? So now we have methyl, we have ethyl. So in this case, the alkyl group which has bigger size will go with amine, and this will go as alkyl group. So then, as you can see here, methyl and normal. So methyl, and this will go as ethane amine. Ethane amine, because the alkyl group which is bigger in size will go with amine, whereas the alkyl group which is small in size will remain as alkyl in front of the name. So therefore we have here, even though we have two alkyl groups here, methyl and ethyl, methyl will come first. Methyl, then bigger size, because the size of this ethyl group is bigger than methyl, that will go as with amine. So methyl, ethane amine. So methyl, ethane amine. Now let's look at general method of preparation of amines. Generally, preparation of amine is very easy process, because you can just react ammonia with any alkyl halide. So here, if you react ammonia with alkyl halide here, then you'll get primary amine. So what you want to put inside this structure, if you want to put methyl, you take methyl halide. If you want to take ethyl group, you take ethyl halide. If you want to take propyl group, then you take propyl halide. You can take what you need. According to your need, you can take this alkyl halide and then just put it there. When you take alcoholic solution of ammonia and react with alkyl halide, then we get primary amine. So again, this is a general method of preparation, because we have not specified what is R here. And now, specific, let's look at this one. So now this is primary. Now secondary, if I want secondary amine, then what I'll do is I'll take primary amine. When it reacts with another molecule of alkyl halide, then two hydrogen atoms will be replaced, resulting in the formation of secondary amines. Now if you take secondary amine, which is formed in step 2, and again react with alkyl halide, then it will result in the formation of tertiary amines again. So again, let me go back again. Now, again, as I told you earlier, this alkyl group can be anything. Suppose I have added methyl here. It's not necessary that I have to put methyl in this group also. It's not necessary that I have to take methyl halide here. I can take ethyl. If I want to introduce ethyl into this structure, then I can take that alkyl group. So whichever alkyl group you want to introduce into the structure, take that alkyl halide. So it's not necessary. When we take this tertiary alkyl halide, these three are maybe of same type or may not be of same type. It can be prepared according to the needs. Now, second method of preparation, which is very important, is Hofmann degradation method. Also, this method is sometimes called Hofmann bromide degradation method, and it's very common method that's used in chemistry for preparation of any amines. Now, as you can see here, in this method, we always take amides, and when you react amides with bromine water in the presence of base, we get amine. Amide gets converted into amine, but during the process of conversion, the number of carbon atom will get reduced by 1. So again, what's Hofmann bromide degradation? Is a reaction in which amides are converted into primary amine by reacting with bromine and base. If you look at this one, we are taking ester amide in the presence of bromine and base. Now, as I told you earlier, always in the product, the number of carbon atom will be reduced by 1. So here you can see, here we have 2 carbon. Now we just have 1 carbon here, because this will go as CO3, K2CO3, potassium carbonate. Therefore, we get methylamine. Now, let's assume that we want to prepare ethyl amine. I want to prepare ethyl amine in lab. Then I can take here, instead of taking ester amide, I can take propanamide. If I take propanamide, then I'll get ethylamine here, because when you get the product will always have one carbon less than the reactant amide. So again, therefore, second method of preparation of amine is Hofmann bromide degradation, and this is a method in which amides are converted into primary amines by reacting with bromine and base. Now, let's discuss about the chemical properties of amines. All amines behave as base because they can accept proton due to presence of lone pair of electrons on nitrogen. So as we have discussed already in the beginning of the lesson, ammonia, as you know that in ammonia, the nitrogen atom bears one lone pair of electrons on it. Therefore, it becomes base. As per the definition of Lewis concept, base is any substance that donates lone pair of electrons. So now this is a base. So even if it is a primary amine, it will still remain base. It will still behave as base. Even if it is secondary amine, it will still behave as base. Even if it is tertiary amine, it will still behave as base. Now, let's look at this one. The basicity of amine increases in the following order. First, aniline. Now, let's look at this too. Why aniline is less basic than ammonia? Let's try to understand this. Now, ammonia is a base because it donates this lone pair of electrons to a proton and forms a coordinate bond. Now, in case of aniline, the lone pair of electron which is present in a nitrogen atom is pumped into the benzene ring due to resonance. Hence, this lone pair of electron is less available for protonation. It is not as available as it is there on the nitrogen atom of ammonia. Hence, this is less basic compared to ammonia. Now, let's compare. So, therefore, first it will be aniline first. Aniline is less basic because the lone pair of electron present in nitrogen atom is pumped into the ring, hence it is less available. Then comes ammonia. Here at least this lone pair of electrons is available for donation, but it is less available because it is pumped into benzene ring due to resonance. Now let's look at third one. Methylamine. Let's look at this one. Why methylamine is more basic than ammonia? Now the reason is because all alkyl groups are electron releasing group. They have positive I effect. So here you can say here these are the shared pair of electrons that's present between carbon and nitrogen atom. So since it is electron releasing group, the electron density around nitrogen atom will increase. So since the electron density around nitrogen atom will increase, the donation of this lone pair of electron becomes easier. Hence, it will be stronger base compared to ammonia. And the reason, again, as I told you, it is electron releasing group. All alkyl groups are electron releasing group. It pumps electron into the nitrogen atom. Hence, the electron density on nitrogen atom increases. Hence, the donation of this lone pair of electrons becomes easier. Now, as you can see here, methylamine is less basic than ethylamine. Let's try to understand why ethylamine is more basic than methylamine. Now, please try to understand this. Alkyl groups, methyl, C2H5, ethyl, C3H7, propyl, all these are electron releasing group, no doubt. But as you come down, the electron releasing power increases, which means bigger the size of alkyl group, more is electron donating power. Higher will be the positive I effect. Therefore, in case of ethylamine, this has greater positive I effect, which means it has greater electron donating effect. Hence, if the electron density here is this much, here the electron density on this nitrogen atom will be more, because ethyl group has more electron donating power. It has pushed more electrons. Hence, the donation of these electrons becomes much easier. As a result, this will become strongest base among these 4 structures. Aniline, again, let me just revisit, weakest because lone pair of electrons is pumped inside the benzene ring, hence it is less available for protonation. So it is not as basic as ammonia is. Again, if you look at methylamine is more basic than ammonia because in methylamine, this methyl group which is attached to nitrogen atom is electron releasing group. It releases electrons to the nitrogen atom, thereby increasing the electron density of nitrogen atom. Hence, the donation of lone pair of electrons becomes easier. And finally, ethylamine is strongest among all this because as the size of alkyl group increases, electron donating power increases. So ethyl group has more electron donating power than methyl. So hence, the electron density around the nitrogen atom of ethylamine is more than that in methylamine. Hence, the donation of this proton becomes much easier. Hence, it will be the strongest base. So let's look at this one. Aniline is less basic than ammonia and other aliphatic amine because the lone pair of electrons present in nitrogen atom is delocalized into the ring, benzene ring. Hence, it is less available for protonation. Ammonia is less basic than other aliphatic amine because it does not contain any electron releasing group attached to nitrogen atom. Methylamine is more basic than ammonia because it contains electron releasing methyl group. This makes the donation of lone pair of electrons easier. Ethylamine is more basic than methylamine because as the size of alkyl group increases, the electron releasing power also increases. That's positive I effect increases. Hence, the lone pair of electrons present in nitrogen atom of ethylamine can be donated more easily than the lone pair of electrons present on nitrogen atom of methylamine. So now the last subtopic that we have in this lesson is the test to distinguish primary amine from primary aliphatic amine from primary aromatic amine, and this test is known as azo-Dye test. Azo-Dye test. So it is a test that is used to distinguish primary aliphatic amine from primary aromatic amine because this test is given by primary aromatic amine, but this test is not given by primary aliphatic amines. Now, I'll just briefly explain about this one before you watch a video about this test. So here, in this test, first we take aniline, along with sodium nitrite and acid. I'm taking 2 molecules of acid, HCl. Now, this will go as NaCl. So I'll get NaCl. Then this S2, and this O2 will go together as 2 molecules of water. Now you can see this is gone. Now here I am left with nitrogen. Now this nitrogen will form a bond with this one. So this nitrogen will form first 3 bonds and like this. But now if you have this type of bond, yes, second nitrogen is stable here because it has fulfilled all its valency, but this nitrogen is not because out of 3 valency it has just fulfilled 2. So therefore, third one it will form coordinate bond here. So that results in the formation of positive charge, development of positive charge on this nitrogen atom. Hence, this will be Cl. This Cl1 minus will come here and form benzene diazonium chloride. Benzene, B-E-N-Z-E-N-E, benzene diazonium salt, or it's also known as benzene diazonium chloride. So we get this one in first step. Now this benzene diazonium chloride, when it reacts with beta naphthalate, then we get a brilliant orange red dye. So we are taking this in second step, you are taking this compound and making it react with beta naphthalate. So naphthalene, I think you have seen naphthalene ball. So naphthalene, but in beta position we have alcohol group, OH group. So this is beta-naphthyl. So here, what happens here? As you can see, this hydrogen will go with this one to form HCl, and this results in the formation of new compound. And we recognize this compound due to appearance of orange red dye. It is a dye. So therefore, this is a test. So to understand better, please watch this video.
Now, in terms of ingredients, this is what I used. Both the p-nitroaniline and the sulfuric acid were made in previous videos. The other three ingredients were purchased online. So to start things off, I get a beaker and I fill it with about 50 ml of distilled water. Then I turn on the stirring and add a small amount of concentrated sulfuric acid. When it's all mixed in, I add 5 grams of the p-nitroaniline. Some of it's going to dissolve into solution, but most of it stays as a solid. At this point, the mixture is quite warm, and now I need to cool it. To do this, I set up an ice bath, add a thermometer, and wait for it to get to around 5°C. When the reaction mixture finally hits the 5°C mark, I start to slowly add a solution of sodium nitrite. Every time it's added, this mixture will heat up a little, and the p-nitroaniline will slowly disappear. So what I'm doing here is a reaction between the p-nitroaniline and the sodium nitrite in the presence of an acid to form a water-soluble diazonium salt. The sodium nitrite doesn't react directly though. It's first converted to the electrophilic nitrosonium ion by the sulfuric acid. The amine group of the p-nitroaniline then attacks it, a lot of electrons bounce around, and it leads to the formation of the final diazonium salt. The newly formed nitrogen-nitrogen triple bond is not very stable though, and it'll start to degrade if the temperature rises too much. So because of this, it's very important to keep the reaction below 10 degrees Celsius. However, even below 10°C, some degradation will probably still occur. If it does, it'll start to release nitrogen gas, which can sometimes cause a very small amount of bubbling or foaming. So the solution of diazonium salt is now ready, but we're not quite done yet. To make the dye, I need to couple it to something else, and in the case of para-red, this other chemical is called 2-naphthol. I need to make a solution of this, and I start with about 100 milliliters of hot water. I add a small amount of the 2-naphthol, and then I slowly add sodium hydroxide solution until most of it dissolves. What I'm doing here is converting the normally insoluble 2-naphthol into a water-soluble sodium salt. Then to this solution, I add the material that I want to dye. I just went with a cotton ball and a piece I cut out from a sock. I thoroughly mix them around, and then I let them soak for about 5 to 10 minutes, just to make sure that they pick up the naphthol. I can't let them sit here too long though, or else the sodium hydroxide could start attacking the cellulose fibers. About 10 minutes later, I remove them, and I squeeze out the water. I then use some paper towel to dry them up as much as possible. The last thing to do is to make a dilute solution of the diazonium by adding about 5 milliliters of it to 25 milliliters of water. I dip my sock piece into it first, and you can see a very nice red color immediately appears. Then, on top of this, I just throw in the cotton ball. I gently mix them around, but then I let them sit there for several minutes just to make sure that the dye fully forms.
So after watching this video, you must have understood how azo dye is prepared and how it can be used to distinguish primary aromatic amine from primary aliphatic amines. So now we have almost come to the end of our lesson. So before we conclude this lesson, let's revisit the important areas that we have studied on this topic. We have looked at the definition, we have looked at different types of amines, primary amines, secondary amine, tertiary amine. We also look at how the basicity of amines differ from one another. We also have looked at how to write the IUPAC name and common names of different amines. And finally, we have looked at how we can prepare amines in the lab. And then with this, we have come to the end of our lesson. Before we conclude the lesson, please go through these questions. First question, why the basicity of amine increases in the following order? Secondary amine is most basic, then primary amine, then comes tertiary amine, ammonia, and aniline. Please explain, explore, maybe go through different textbook, get help from your chemistry teacher, and try to get answer for these questions. And second one, state any two applications of amines in maybe day-to-day life. So hope you have enjoyed today's lesson. See you in next lesson. Thank you.